Hi everybody, we're back with Statistics Chapter 9 for 367. So this is talking about the t-test for independent groups. So basically when you're doing data collection here, what you need to decide is which test is applicable to you. So that's what we're going to try to determine here. So it works to determine the difference between the means in two sample groups. So what is the level of measurement for the outcome variable? Are there two samples? You have to have two samples to complete this test. Are those samples independent of each other? And keeping in mind that independent means they're not connected in any way. And then they must be at interval or ratio level. And just as a little reminder here, an interval is an exhaustive, exclusive, and rank ordered list with equal intervals. So for example, temperature being higher or lower by 1 degree, 2 degree, whatever. And ratio is all of the above and at a point in which the measurement doesn't exist. So weight would be an example of that. You can't weigh negative 0.2 pounds. It's either you're at 0 or you're, 492. So your example for this is just in the book was actually 2 types of epinephrine injectors. So the goal here was that it was 2 different brands, so they're totally different, and they were independent. We never mixed one brand with another. So we didn't perform one test with one brand, and then the next go round we performed it with the second brand on the same patient, and these were totally separate tests. And then our measurement was heart rate, which of course is absolutely a ratio level measurement because you can't have a heart rate of anything less than 0. So as far as the experimental stuff is concerned, it's the same process as the chi-squared test. So the null hypothesis would be that there is no difference in your samples. The alternative hypothesis is that there is a difference, whatever difference you were looking to find. Significance is still determined by the alpha, which is that level of risk you're willing to take, and we do still need to determine the degrees of freedom, which in this particular example is n1 plus n2, and then all of that is -2. So you actually look that number up on a t-test table, just like we did with the chi-squared example, and that gives us our data. The test can either be one-tailed or two-tailed, meaning that we expect it all to just, on a bell curve, we're going to tail on one side or versus both sides. So one tail is acceptable when you're doing a non-inferiority trial. So what that means is, for example, is we're not trying to prove that one intervention is better than another intervention. We're trying to prove that it's no worse than another one. So this isn't necessarily really useful in a lot of science applications. It's not very reliable, and it's very easy to skew data in a desired direction. So a lot of marketing companies use a one-tailed test in order to skew the data in their favor. We also need to run something called a Levene's test, and that just determines the variances in your sample or your population group. It basically tests that a null hypothesis is that there are equal population variances. So that means your sample groups were essentially the same. So if the p-value found by the test is less than significant, then the obtained differences probably didn't occur by chance. So that's when we're actually seeing a difference in the two groups. It matters because a t-test is needed to assume or not assume equal variances. So the way that we actually run the statistical analysis is different based on if those variances exist or if they don't. So you can kind of see that here on the side over here. So our null hypothesis is that everything is equal, right? So one side equals the other side because it is a bell curve. Our alternative hypothesis says they're not equal, that there's a difference here. And so you can kind of see the value of x changes based on those hypotheses. So how do you perform a t-test? You do not need to do the math, but this is a little bit more complicated, so I found a good video that kind of just demonstrates what we're trying to see here. I'm going to post this video in the next link. My internet's not supporting this enough to play it in this video, so if you're interested in figuring out how the t-test actually looks on paper, that link will be posted for you as well. As always, any questions, let me know.